the inverse, cotangent, secant, cosecant functions. So first we would like to talk about the inverse cotangent function. Cotangent inverse function. So we need to restrict the domain of cotangent to the interval from 0 to pi, so the function is 1 to 1 and the inverse exists. Because as you remember, the cotangent function has asymptotes in pi, 2 pi, and cotangent function goes through pi over 2, so the cotangent function goes like this. At 0 there is an asymptote right here as well, and of course n minus pi is another asymptote, and the graph goes like this: pi over 2 minus pi over 2 pi over 2. This is y is equal to cotangent x. That's a cotangent function. So this function is certainly not 1 to 1 because it does not pass the horizontal line test. That means any horizontal line can touch the graph at most once, and here would cut 2 or 3 times. Therefore, we need to restrict the domain. If we just take one period from 0 to pi, then this function only is 1 to 1 and the inverse does exist. So as before, we would like to draw the inverse as before. That's my cotangent function with the restricted domain. With the restricted domain from 0 to pi, here is my asymptote. Okay, here we have 0, x-axis and y-axis. And I'm gonna use the overhead to get the inverse. So this is my cotangent function, and the inverse is the reflection by the line y is equal to x, so by this line. So my overhead, I need to flip it, reflect it, I need to flip it and reflect it, and here's the inverse. Okay, so the red, basically we switch x with y's. So the red graph right here, that's my inverse. This one is y is equal to cotangent inverse x. Okay, and in that case we have the asymptote right here on the pi, but on the y-axis. And everyone can see that it is reflected by the line y is equal to x. So let's identify domain and range of the inverse. Domain and range of the inverse. Domain of cotangent inverse. So domain is the window on the x-axis. The graph keeps going from everywhere from minus infinity to infinity. So domain is all real numbers, or from minus infinity to infinity, and range. Range of cotangent, range is the window on the y-axis. Range is the window on the y-axis, so my red graph is right here between 0 and up to this point, which is pi. So from 0 to pi. And there is no asymptotes. Now we would like to talk about the inverse of the secant function. The inverse of the secant function. secant inverse. As we remember, the secant function, secant y is equal to secant x, is the reciprocal function of 1 over cos x. So the graph of the secant comes from the cosine function. Cos function was like this, v-shaped. So here was 2 pi, here is pi, and half pi. So the secant has asymptote at half pi, and the graph was going right here. And the graph was going right here. So this one was minus pi over 2, this is pi over 2, and this graph goes right here. Okay, and the other part graph goes right here. So we do need to restrict this domain. First, we cannot take just this one bump because this one is not one-to-one. If you take horizontal line, it is not one-to-one. So we do need to take from one part and this part only. So we're gonna take this part and this part of the secant graph. Okay, so therefore I'm restricting my domain from 0 up to pi, from 0 to pi, but except the asymptote, right? We need to take out the asymptote. So the domain is from 0 to pi, so I'm considering only those two parts of my secant graph, and those graphs we're gonna reflect and get the secant inverse. So as before, I'm gonna use the overhead. So that's my secant restricted to 0 to pi. From 0 to pi, 0 and pi we have right here. 0 to pi. Okay, that's my secant restricted from 0 to pi. And now I'm gonna use the overhead for overhead. Here we go. That's my secant, and I need to reflect, so I need to flip it over and interchange x with y's. So that's my inverse. The red graph is going to be my inverse right here. Right here, and this part. And this part right here. So this one is my secant inverse. Secant inverse x. And you can see that it is reflected by the line y is equal to x. Here is the line y is equal to x. So this part is clearly reflected, and this part is reflected on the other side right here. Okay, so now we have this, and the asymptote goes on the y-axis right here. Secant inverse. So let's identify the domain. Let's find the domain of this function. Of secant inverse. Domain of secant inverse. Domain is the window on the x-axis. Domain is the window on the x-axis. So the graph keeps going up to this point, and this point was 1 on the y. So this point is -1, and this point is 1. Okay, so we don't have any graph in this window, the red graph. So the domain will be from -infinity up to 1, and then from 1 to infinity, because that's the window where we have. So we have -infinity up to -1, and then we have 1 to infinity. And range of secant inverse is the window on the y-axis. So the value is from 0 up to pi except the asymptote. From 0 up to pi except the asymptote. So we have from 0 to pi and take away the asymptote pi over 2. In the curly bracket we denote this set with one element only. And now we would like to find the inverse of the cosecant function. Of the cosecant function. Let's recall the graph of the cosecant. So it's gonna be inverse cosecant inverse, and we need to restrict the domain of cosecant to this graph. Let's recall that cosecant x is nothing else 1 over sine x. So what was the graph? The graph of sine is the S shape, right? So here was 2 pi, here is pi. So now we have asymptotes at pi, 2 pi, and the cosecant graph is right here, and right here. Here would be another asymptote, right here, another asymptote, and so on. Okay, that's the cosecant graph. So now we cannot take just this part, and on the other side it would be minus pi is the another asymptote, minus pi, and the graph is right here. Okay, so we cannot take only 1 from 0 to pi because this graph is not 1 to 1. So we can only restrict the domain as we did before. We take this one part and we take this one part. So up to this value is pi over 2, and up to this value is minus pi over 2. That's why we restrict the domain of secant from minus pi over 2 to pi over 2, and we take away the asymptote. At 0 was the asymptote, right? So we take away the asymptote. So this graph of the secant, the graph of the secant is right here. It's from minus pi to pi, and at 0 there is an asymptote, and I'm gonna use the overhead. I'm gonna use the overhead to find the inverse. Oh, that's already the inverse. I'm sorry. That's this cosecant function. That's the cosecant function restricted to minus pi over 2 to pi over 2, and now we're gonna flip it over and have the inverse right here. So the inverse is right here. That's the inverse, and on the other side it goes from here up to here. And now we will have the asymptote on the x-axis right here. Okay, and here was my pi over 2 to minus pi over 2. So the red one is cosecant inverse x. And let's find the domain and range of the inverse. Domain of cosecant inverse x. Domain on the x-axis. So we have graph from minus infinity up to this point, and that point is minus 1. And then from this point to infinity, so from 1. So we have minus infinity to minus 1, and then from 1 to infinity. And range of cosecant inverse. Range of cosecant inverse, it goes from this point up to this point, from minus pi over 2 to pi over 2, without the 0. There is an asymptote there. So from minus pi over 2 to pi over 2, minus 0. So now we have some example using the inverse, using the inverses. Example 1. Find the exact value. Find the exact value of each expression. Sine of cos inverse of 1/3. If we check, we don't have the cos inverse. If we check on our chart, we don't have cos of 1/3. We don't have cos of 1/3. So we need to solve it using other means. So how do we do it? We set up first that this function is my theta. We can set up that this function inside is my theta. Okay? So let theta is equal to cos inverse of 1/3. Then if I take cos of both sides, cos and cos inverse cancel out, so I will have that cos theta is equal to 1/3. That's the first step we're gonna do. Always set up the function inside as a theta, and then take the cos of both sides over the function you have to change this inverse, that cos theta is 1/3. Now we do need to identify the quadrant of the theta, the quadrant in which we are. So how do we do it? First, we get the restriction from cos inverse. From cos inverse. So cos inverse was restricted from 0 up to pi. So we have that theta belongs to 0 up to pi in order that the inverse exists, in order that the cos inverse exists. Okay? And now we have that cos theta is positive and cos theta is positive because we have cos theta is 1/3. So those are the two restrictions, and we need to figure out the quadrant from that. So when I do the coordinate system, we know from the angle from this to this point is pi over 2, and if I open from 0 up to here, then I would have pi. So from 0 to pi, I have two quadrants, first and the second. And cosine is positive. We go with the story, add sugar to coffee. Cosine is positive only in the first and the fourth quadrant. So both quadrants gives me that cos is positive, and the restriction from 0 to 2 gives me the first quadrant. So my theta in first quadrant Okay, I got the restrictions from those two things. First, cos inverse must exist. Restriction of cos inverse is from 0 to pi, in order that the inverse exists. So from 0 to pi, I have two quadrants to consider, number 1 and quadrant 2. And second restriction comes from this one, that cos theta is 1/3. That means cos is positive. Cos is positive in the first one, and cos is positive in the fourth quadrant. So both restrictions from 0 to pi and cos positive gives me the first quadrant. Once we identify the quadrant where my theta is, then we can find the value. So I have cos theta is equal to 1/3. I set up the triangle. I put that my theta is here. We know that cos is adjacent over hypotenuse. So my one value is right here, and hypotenuse is right here. And then we will need sine. Sine is opposite over hypotenuse. So I do need this value. So we can set up that this is my y. And use Pythagorean theorem that 1 squared plus y squared is equal to 3 squared So y squared 1 plus y squared is equal to 9. Bring this over, so y squared is equal to 9 minus 1, which is 8. And take square root of that. So y is equal to plus or minus square root of 8. And whether you choose plus or minus, it depends on what quadrant is your theta. Depends what quadrant did you identify. So in our case, we are using plus root of 8. And we can leave it root of 8, or we can rewrite that this one is root of 8. We can write that this one is 4 times 2. When you have multiplication, you can separate the roots. This one is root 4 times root 2. And this gives me nothing else. Root 4 is 2 and root 2. So this one is 2 root 2. Okay, so that's this value is 2 root 2. So now my final answer, I'm looking at my final and my original question. I need to find sine of cos inverse of 1/3, and we said that cos inverse of 1/3 is theta, so I need to find sine theta, and sine theta in this triangle is opposite over hypotenuse, so opposite is 2 root 2 over 3, and I'm choosing the positive value because of the quadrant. So that's the final answer. So two things to do in order to solve question like this. One, set up the function inside as theta and make the right triangle. And then another one, identify what quadrant you are. It depends on the restriction of the cos inverse, the inverse function, and the value you have, whether it's positive or negative. And once you solve the triangle, then you have sine theta, and sine theta is opposite over a hypotenuse, and that gives you the value. Example number 2. Example number 2. Tangent of sine inverse of minus 1/2. Sine inverse minus 1/2, we have exact value. You can get this from the chart and then you can solve it immediately. Or we can do it as before using the triangle. So first thing we're gonna do, we're gonna set that the function inside is my theta. Okay? So we're gonna write let theta is equal to sine inverse of minus 1/2. Now I take sine of both sides, so we have that sine theta is equal to minus 1/2. Then set up your triangle, and we do need to identify the theta. So we get what quadrant we are, theta, what quadrant we are. So first we get the restriction of sine. For what angle, for what theta does the sine inverse exist? So restriction sine inverse of x exists for what theta? For theta from minus pi over 2 to pi over 2. And second restriction is that my sine is negative, and sine x is negative. So let's see what quadrant this would give us. From minus pi over 2 to pi over 2. So if I go this way, I would have from 0 up to this point is pi over 2 or minus pi over 2. So this gives me the quadrant number 4. and up to pi over 2, so this gives me 0 pi over 2 is quadrant number 1. Basically speaking, I'm separating this interval minus pi over 2 to pi over 2 into 2, minus pi over 2 to 0, and then 0 to pi over 2. So the angle from 0 to pi over 2, I'm opening positive direction, so it's from 0 up to this axis, pi over 2. And then in negative, from 0 up to negative pi, negative half pi, pi, and so on. So that gives me those two quadrants. And now sine is negative. If I go with my story, add sugar to coffee. Sine is positive here, sine is positive, sine is negative, negative in this quadrant, and sine is negative in this quadrant. So those two restrictions gives me the fourth quadrant. Fourth quadrant. My theta is in fourth quadrant. Once I identify the quadrant, I don't worry about minus or plus, because then I just use the triangle straightforward. We have theta. Sine is opposite over hypotenuse, so 1 over 2. 1 over 2. Or if you want to go with the point, in fourth quadrant it will be positive and negative on the bottom, so the other value is negative. Okay, so now I need to find this value x, so I'm going with Pythagorean theorem that I'm getting 1 squared plus x squared is equal to 2 squared. So I have 1 plus x squared is equal to 4. Bring that 1 over, so x squared is equal to 4 minus 1 or 3. Take square root, so x is equal to plus or minus square root of 3. And whether we choose plus or minus, it will depend on the quadrant we are. It will depend on the quadrant we are. Okay? So now we're gonna go with the tangent. We need tangent of my theta. My theta is in the fourth quadrant. Tangent in the fourth quadrant is negative. So we're gonna use the negative value. Okay? So I'm looking what I have, tangent of sine inverse of minus 1/2. As we said, this one was theta, so I have tangent of theta. Tangent is opposite over adjacent, so I will have 1 over root of 3. 1 over root of 3. But now tangent is in the fourth quadrant, we're gonna put minus right here. So the final answer is minus 1 over root 3. So the best way to do it is to set up triangle. First set up the function inside is theta. Then don't worry about minus, this only tells you what quadrant you are. Then do the triangle from the function that it's opposite over hypotenuse or depends on the function what you have. Solve for the missing variable using Pythagorean theorem. Then identify the quadrant. The quadrant we identify using the inverse. When does the inverse exist? That's the first restriction. And second restriction from the given data. This one was theta, so your sine theta is negative. Sine is negative, and those two restrictions gives you the quadrant. Once you have the quadrant, then you can easily set up your final answer with the minus. One more example, see? Secant of cos inverse of 1/7. There is no 1/7 exact value in the table, so we do need to find the exact value. secant is 1 over cos, but 1 over cos is not the same as cos inverse. Be careful about that. Okay, as before, we set up that this one is my theta. We set up that this one is my theta. So let theta is equal to cos inverse of 1/7. Take the cos of both sides, so cos theta is equal to 1/7. Now let's identify the quadrant we are in. Let's identify the quadrant we are in. So cos inverse, restriction cos inverse exists. For what cos restriction of cos function? Restriction of cos function we have for 0 to pi. Cos function needs to be restricted from 0 to pi. Okay? And now we have cos positive. And cos theta is positive. So let's see what quadrant that gives us. From 0 to pi, when I keep opening from 0 half pi, from 0 to pi gives me those two quadrants, first and second. And then I have add sugar to coffee. So cos is positive in the first quadrant. We can have theta, cos theta everywhere. And cos is positive in the fourth quadrant. So from 0 to pi and cos positive gives me the first quadrant. Theta is in the first quadrant. So all values will be positive. So now I set up my triangle. I have theta. Cos is cos is adjacent over hypotenuse. Adjacent over hypotenuse. So now let's see if we even need to find the y value. Sometimes maybe we don't need to find the y value. Since secant is 1 over cos, so the value would be opposite y. So secant theta of cos inverse of 1/7. This gives me secant theta. And secant theta is 1 over cos theta. So this would be hypotenuse over adjacent. So this one is 7 over 1. First quadrant we are plus. So the final answer is just 7. Not needed to find the y value. It depends on this function or the outside function whether you will need this value or not. One more example. The secant of tangent inverse of 1/3. As before, we set up that the function inside is my theta. So we have that tangent theta, let theta is equal to tangent inverse of square root of 3. Take the tangent of both sides. So tangent theta is equal to square root of 3. Restrictions. Tangent inverse exists for theta. For what theta tangent inverse exists from 0 to pi. Tangent theta, actually tangent, for tangent we had the restrictions, that was this part, right? Tangent theta was this part, so it's from minus pi over 2 to pi over 2. Minus pi over 2 to pi over 2, we had the restrictions for tangent. And then we will find then tangent is positive. Try to find the quadrant. And then tangent is positive. So we will identify the quadrant we are in. From minus pi from minus pi half, it's right here, minus pi over 2 this direction, and this way I would go, it's pi over 2. So we have those two quadrants to choose, and tangent is positive, add sugar to coffee. Tangent is positive in the first one and in the third one. So that gives me the first quadrant. Theta is in first quadrant. Theta is in the first quadrant. So in that case, we have the value of theta for pi over 3. The value would be, the theta would be that tangent theta is root 3, is in the table, and this gives you the value of pi over 3. And then we can find the secant of pi over 3. That would be one way to go. Or in other, as we did before, set up your triangle, put theta, tangent pi over 3 is like pi over 3 over 1. Tangent is opposite over adjacent, so we will have root 3 over 1. And for secant, we do need to find the hypotenuse. So I'm going to set it that this is my r, and then I use quadratic formula that 1 squared plus square root of 3 squared is equal to r squared. So this gives me 1 squared is just 1. 3 square root of this one cancel out, so I have 1 plus 3 gives me r squared. So 4 is equal to r squared. Take the square root. So r is equal to plus or minus square root of 4, which is plus or minus 2. But the radius is always positive, so the value is 2. So now I'm starting from the beginning, secant of my theta, secant of tangent inverse of root of 3 is equal to secant theta, and secant theta is 1 over cos, and cos is adjacent over hypotenuse, so in that case would be hypotenuse over adjacent, so it would be 2 over 1, which is 2. I'm in the first quadrant, the value is positive. That's my final answer.